Okay, so I'll go for one example. So we've got two independent discrete random variables x and y with the following probability generating functions. We want to find the probability generating function for the sum of x and y. And again, this example is in your book, so you're welcome to have a look in there as well. So to find the probability generating function for z, you do the probability generating function for x and times by the probability generating function for y. And it's that straightforward really. So it's a half plus a half t multiplied by a third plus a half t plus a sixth t squared. So if I multiply through by half, and then multiply through by half t, so that's a 12 t cubed. And then collecting like terms together, we've got 1/6 plus 5 over 12 t plus a third t squared plus a 12th t cubed. And then that's done. That's all your possible outcomes because you're multiplying everything in here by everything in here. So it just sorts itself out, and because they're independent, it's fine. And then we can use the probability generating functions to show that the expectation of z is the expectation of x plus the expectation of y. So again, there's nothing too complicated going on. To find the expectation of z, we need to differentiate and substitute in, t is equal to 1. So differentiating, we get 5 over 12 plus 2/3 t, so just timesing by the power, taking one off, plus a quarter t squared. And so substituting in t is equal to 1. You get 16 over 12. And so the expectation of z is equal to 4/3. And then if we do the same for x and y, so expectation of x is probability generating function for x with 1 substituted in. And so differentiating that one, you just get a half. And so the expectation of x is equal to a half. So it's absolutely fine to have no t's in there. And then doing the same for y. This example feels a bit easy for you really, but I'll finish. I've started, so I'll finish. So differentiating the probability generating function for y. I need to find it. Generating function for y is up there. So I get a half plus 1/3 t. My oven's beeping at me because dinner's ready as well. So substituting in t equals 1, we get a half plus a third, which is equal to 5/6. And so the expectation of y is equal to 5/6. And if you do expectation of x plus expectation of y, you get a half plus 5/6, which is 16 over 12, which is 4 over 3, which is the expectation of Z as required. So it's kind of what you want it to be with the expectation. It's not a result you need to know, but that it will always be the case. So yeah, there you go. I'll find some questions for you.